Hello, and a warm welcome to Sleep Science. I'm so very glad you found your way here. The human mind is a truly mysterious place, and it becomes even more so when we close our eyes and drift into the realm of sleep. Tonight, we will explore one of consciousness's most beautiful puzzles: why our dreams so often slip away like morning mist, fading into memory even as we desperately try to hold on to them. Wherever you find yourself right now, perhaps lying in bed with the lights turned down low, or settling into your favorite cozy corner, allow yourself to simply rest here with me. Tonight, we will journey through 100 fascinating truths about the intricate dance between dreams and memory. We'll explore the sleeping brain's hidden choreography, the very chemistry of forgetting, and those strange, fleeting moments when we become lucidly aware inside our own dream worlds. Each fact will be a small step, leading us deeper into understanding the night. If this thoughtful journey through the mind helps you to slow down, a gentle like helps other curious minds drift this way. It's just one quiet tap, helping one sleepy soul at a time. It truly means the universe to us. But please, feel no pressure at all. Just knowing you are here is more than enough. For now, you don't need to do a single thing. Just let your shoulders soften. Let your breathing fall into its own natural, easy rhythm. Imagine yourself floating in a space where thoughts can bloom and dissolve like gentle waves on a distant shore, questions without answers, mysteries without solutions. Now, if you're ready, let's begin our gentle exploration of why we forget our dreams. If you'd like, you can close your eyes now and take a slow, deep breath. Imagine you are part of an endless stream of consciousness, a place where thoughts bloom and dissolve like waves on the ocean. They move without boundaries, without a specific destination. Let go of all limits. Let your mind drift through this boundless space of awareness. And when you're ready, we'll begin. Research suggests that most of our dreams vanish within mere minutes of waking, with the vast majority fading completely before we can fully capture them. This rapid forgetting occurs because the brain handles dreams very differently than it does waking memories. During sleep, the hippocampus, our brain's dedicated memory-making center, shifts into a unique mode of operation, one that doesn't prioritize the long-term storage of what we dream. Instead, dreams appear to exist in a temporary mental buffer, like intricate sketches drawn in sand, destined to be washed away by the incoming tide of waking consciousness. This isn't a flaw or a failure of our minds. It's a carefully designed feature. The brain has compelling reasons for letting most dreams fade, even if those reasons sometimes frustrate us when we wake with only the faintest fragments of a beautiful or meaningful dream still clinging to our awareness. The hippocampus actually changes its core function during different stages of sleep. When we're awake, it is actively encoding new memories, stamping our daily experiences into our long-term storage systems. But during REM sleep, the stage where most of our vivid dreams occur, the hippocampus operates in a completely different manner. Levels of a neurotransmitter called acetylcholine rise to nearly waking levels, and this biochemical shift dramatically affects how the hippocampus processes information. Rather than carefully filing away new experiences for permanent storage, the REM sleep hippocampus seems to be busy replaying and reorganizing existing memories. Dreams may simply be a byproduct of this complex reorganization. The content we experience in them reflects the brain sorting through memory fragments. But the hippocampus itself isn't engaged in the specific encoding mechanisms required to remember the dream. It's a fascinating paradox. The very organ responsible for memory is too busy with other work to remember the work it's doing. Waking up during or immediately after a period of REM sleep significantly improves dream recall. Studies from the Lyon Neuroscience Research Center in France found that people who naturally wake up more frequently throughout the night remember substantially more of their dreams than very deep sleepers do. This is because memories require a brief period of conscious processing to successfully transfer from short-term to long-term storage. When we wake directly from a dream, we essentially catch it in the act, before it has fully dissolved. The dream is still active in our working memory, like a program running in the background of a computer. If we remain asleep, that program closes without ever being saved. But if we wake up, even for just a few seconds, we have a window of opportunity to acknowledge the dream's presence, and that single act of acknowledgement is like pressing the save button. Deep, uninterrupted sleepers may have just as many dreams, but they sail right through them without these crucial moments of conscious contact. It turns out that specific neurons may be actively promoting this forgetting during REM sleep. A landmark 2019 study, published in the journal Times Science*, identified a unique population of neurons that fire specifically during REM sleep and appear to deliberately suppress the formation of memories. These are called MCH neurons, which stands for melanin-concentrating hormone neurons. Located deep in the hypothalamus, they send direct connections to the hippocampus. When researchers artificially activated these MCH neurons in mice, the animals performed worse on memory tasks. Conversely, when they silenced these neurons during REM sleep, the mice's memory actually improved. This suggests that the brain doesn't just passively fail to remember dreams, it actively works to forget them. Since most dream content may not directly apply to navigating our daily waking lives, allowing them to fade may clear essential mental space for what serves us most. These MCH neurons might be the brain's cleanup crew, creating that essential clearing to make room for memories that truly matter. Acetylcholine, a key neurotransmitter, plays a surprising and complex double role in sleep and memory. This chemical is absolutely essential for forming memories when we are awake. In fact, people with Alzheimer's disease, which involves severe damage to these cholinergic systems, experience profound memory problems. During our waking hours, acetylcholine helps the hippocampus encode new experiences. But during deep, slow-wave sleep, acetylcholine levels drop to their lowest point, a dip that is actually necessary for memory consolidation. The brain uses this low acetylcholine period to transfer important memories from the hippocampus's temporary storage to the cortex's long-term storage. Then, during REM sleep, acetylcholine surges back up to near-waking levels. But instead of encoding new memories, this REM stage acetylcholine seems to help integrate and reorganize existing ones. Our dreams occur during this high acetylcholine state, but the neurochemical environment, while similar to being awake, serves a very different function. The presence of acetylcholine without the full suite of encoding mechanisms means our dreams feel intensely vivid but simply don't stick. The prefrontal cortex, a critical region at the very front of our brain, largely shuts down during REM sleep. This area is crucial for logical thinking, self-awareness, and critically evaluating our experiences. When we are awake, the prefrontal cortex acts like a skeptical editor, constantly questioning what we perceive and helping us decide what is worth remembering. During REM sleep, however, activity in this region decreases significantly. This shutdown neatly explains why our dreams can be so bizarre and illogical without us ever questioning them. We might be flying through the air or talking to people who have been gone for years. And within the dream, it all seems perfectly reasonable. But the deactivation of the prefrontal cortex also deeply affects our memory. Without this region's critical input, the brain lacks the evaluative framework that normally helps it decide which experiences to encode into long-term memory. Dreams wash over us without the critical analysis that might flag them as important or memorable. They are experienced, but they are not judged. And without that judgment, they are far less likely to be stored. Dream content often fades away in a very specific pattern. We don't lose all parts of a dream equally. Research consistently shows that the emotional core of a dream, the feeling it generated, often lingers much longer than the specific details of its narrative. You might wake up with the distinct feeling that you had an anxiety dream without remembering a single thing you were anxious about. Or you might retain a powerful sense of joy or peace without recalling the dream's actual events. This happens because different brain systems process different aspects of our experiences. The amygdala, which is the brain's emotional processing center, remains highly active during REM sleep. Consequently, the emotional charge of a dream gets stamped more firmly into our memory than the narrative details do. Meanwhile, the specific images, conversations, and sequences of events rely more heavily on the hippocampus and cortex for encoding and, as we've seen, these regions aren't optimally configured for memory formation during dreams. The feeling outlasts the story because different neural pathways are responsible for preserving them. Some people are simply natural-born dream recallers, remembering them far more than others. The frequency of dream recall varies dramatically across the population. A study published in 2025, using data from 258 individuals, found distinct differences in the brain structures of high and low dream recallers. People who remembered many dreams showed increased white matter integrity in several key regions, including the orbitofrontal cortex and the parahippocampal gyrus. White matter consists of the brain's information highways, the bundled nerve fibers that connect different regions. It seems that better developed connections in these areas support more efficient dream recall. The orbitofrontal cortex, in particular, is involved in sensory processing and maintaining awareness during sleep. In essence, some people's brains appear to be structurally better equipped to capture and hold on to dreams, almost like having a more sensitive internal recording device. This isn't something we choose. It's partly built into the unique wiring of our individual brains. Norepinephrine, another key neurotransmitter, almost completely disappears during REM sleep. This chemical is closely associated with alertness, focus, and attention. When we're awake, it helps us pay attention to important information and consolidate our memories. During non-REM sleep, norepinephrine levels are low but still present. But during REM sleep, they drop to nearly zero. This absence has a profound effect on memory. Without norepinephrine, the sleeping brain lacks the crucial biochemical signal that normally says, "This is important. Remember this: the absence of this neurotransmitter means that even the most intense or vivid dream experiences don't trigger the consolidation mechanisms that would normally preserve them for later recall. The brain fully experiences the dream, but it doesn't receive the chemical instruction to store it. It's like witnessing a spectacular event while a crucial recording device is switched off. The experience happens, but the mechanism to preserve it is temporarily disabled. It's possible that dreams serve a vital function that is specifically related to forgetting unnecessary information. Francis Crick, the famed co-discoverer of DNA's structure, proposed a theory with his colleague Graham Mitchison, suggesting that we dream in order to forget. Their theory, known as reverse learning, suggested that dreams help eliminate spurious memories and unwanted neural connections that form during our waking life. Each day, the brain generates millions of random connections, and not all of them are useful. If we kept every single association, every fleeting thought, and every tangential link between ideas, our mental life would become hopelessly cluttered and confused. Dreams, in this view, act as a nightly cleanup crew. They activate random patterns during sleep, and those patterns that aren't useful or important fail to be reinforced and gradually fade away. The fact that we don't remember most dreams is therefore essential to this process. If we remembered every dream, we'd be cluttering our memory with the very noise the dreaming process was designed to clear away. Forgetting our dreams, then, might not be a bug, but a fundamental feature. The very transition from sleep to wakefulness involves a neurochemical flood that may effectively wash away our dreams. When we wake up, multiple neurotransmitter systems activate almost simultaneously. Norepinephrine comes rushing back. Acetylcholine shifts into its waking pattern. Dopamine and serotonin levels adjust, and the prefrontal cortex powers back online. This sudden cascade of chemical changes creates a completely different brain state within a matter of seconds. Memories are famously state-dependent, meaning we remember things best when we are in a similar mental and physiological state to when we first formed them. A dream formed in the unique neurochemical environment of REM sleep may become incredibly difficult to access once our brain shifts to the radically different state of being awake. It's like trying to recall something that happened in a foreign country after you've returned home and no longer speak the language. The memory might still exist somewhere, but the retrieval pathway has been disrupted by the transition between two fundamentally different modes of brain operation. Dreams might actually help us process our emotions times precisely because times they are forgotten. A 2024 study, published in Times Scientific Reports Times, found that dreaming plays an active role in how we process emotional memories. Participants who reported dreaming showed improved processing of emotional memories compared to those who did not. But here is the most interesting part. The improvement came from processing the emotional content while simultaneously weakening the memory of the specific events that triggered it. Dreams allowed participants to work through their feelings without necessarily retaining all the details of what they had dreamed about. This suggests that forgetting the content of a dream while retaining the emotional learning from it could be therapeutically valuable. We process difficult emotions, update our emotional responses, and integrate our experiences, all while the specific, often bizarre, dream scenarios fade away. The forgetting may protect us from being overwhelmed by the raw intensity of the processing work itself. The timing of our sleep stages significantly affects both the content and the memorability of our dreams. REM sleep occurs in cycles throughout the night, with each REM period typically lasting longer than the one before it. Early night REM periods are short, perhaps only 5 to 10 minutes long. By contrast, the REM periods we experience in the late night and early morning can stretch to 30 minutes or more. Dreams that emerge from these longer, later REM periods tend to be more elaborate, more bizarre, and sometimes more memorable, perhaps because there's simply more time for complex narratives to develop and for brief, spontaneous awakenings to occur. Dreams from early night REM, on the other hand, are often shorter and less vivid, and we are far less likely to remember them because we are still deep in the most restorative stages of sleep. The very architecture of our sleep influences both what we dream and whether we will remember it. Our dream memory depends not just on what happens in our minds, but on times it happens during the night's long journey. The brain's default mode network behaves very differently during our dreams. This is a network of brain regions that typically activates when we are at rest, daydreaming, or thinking about ourselves and others. It's deeply involved in self-referential thought and memory retrieval. During REM sleep, however, the default mode network shows altered patterns of connectivity. Some of its internal connections strengthen, while others weaken. This reorganization may contribute to why dreams feel so personally relevant, but also strange and disconnected from our normal sense of self. The same network that helps us form a coherent identity when we are awake may, during sleep, contribute to the fluid, unstable sense of self we experience in dreams. This altered configuration may also fail to support the kind of memory encoding that preserves experiences for later recall. The default mode network is certainly working during our dreams, but it seems to be working in a way that emphasizes processing over preservation. Young children remember their dreams very differently than adults do. Infants and toddlers spend a much larger proportion of their sleep time in the REM stage, which suggests they may have a rich and active dream life, but they are unable to report on it. As children develop language and can begin to describe their dreams, their reports are often shorter and far less elaborate than those of adults. The ability to recall dreams seems to develop right alongside other cognitive capacities. Our memory systems mature gradually throughout childhood. The hippocampus, for example, doesn't reach its full adult functionality until several years after birth. This means that even if children dream vividly, their developing memory systems may not be capable of encoding those dreams effectively. Additionally, children may lack the metacognitive awareness, the ability to think about one's own thinking, that helps adults recognize and remember a dream as a distinct experience worth holding on to. This developmental trajectory suggests that dream forgetting isn't just about sleep neurochemistry, but also about the ongoing maturation of our memory and awareness systems. Stress hormones, like cortisol, affect our dream recall in complex and often contradictory ways. Cortisol, the body's primary stress hormone, follows a daily rhythm, typically rising in the early morning hours to help us wake up. While higher cortisol levels can enhance certain types of memory formation, they may interfere with dream recall specifically. People experiencing high levels of stress often report either a dramatic increase in dream recall, especially of nightmares, or a dramatic decrease. The relationship isn't simple. Acute stress might wake a person more frequently from REM sleep, providing more opportunities to catch dreams before they fade. Chronic stress, however, can disrupt the entire architecture of sleep and alter the neurochemical environment in ways that make dream memories even more fragile. Studies show that elevated cortisol can interfere with the normal functions of the hippocampus. Since dream recall depends on the hippocampus catching and holding dream content during those crucial moments of transition, stress-related changes to its function can make our dreams even more elusive. The phenomenon of lucid dreaming offers unique insights into the mechanics of dream memory. Lucid dreams occur when a person becomes aware that they are dreaming while they are still asleep. A groundbreaking 2025 study, led by Chate Demirel, analyzed EEG data from multiple laboratories and identified distinct brain activity patterns that occur during lucid dreaming. The research showed increased beta band activity in the right temporal and parietal regions, including an area known as the temporoparietal junction. Beta waves are associated with conscious thought and focused self-awareness. Lucid dreamers also showed enhanced gamma connectivity, particularly in the precuneus, a region involved in self-referential thinking. What's fascinating for memory is that lucid dreamers consistently report much better dream recall. When the brain achieves this state of awareness within the dream, it appears to engage some of the very same circuits it uses for conscious memory formation when awake. This provides powerful support for the idea that much of our dream forgetting is related to the absence of conscious awareness and the specific neural signatures that normally accompany memorable experiences. Sleep deprivation initially impairs our memory, but can, paradoxically, sometimes increase dream recall. When people are severely sleep deprived, their overall cognitive functions decline, and that includes memory. Yet, dream recall often increases dramatically during the first REM-rich sleep period, after a long time awake. This happens because the body enters a state known as REM rebound, generating especially long and intense periods of REM sleep to compensate for what was lost. These extended REM periods produce more elaborate dreams, and their increased intensity, combined with heightened cortical activation patterns, can make them more likely to be recalled upon waking. Additionally, sleep-deprived individuals tend to wake up more frequently from lighter sleep stages, providing more opportunities to catch a dream in progress. This doesn't mean sleep deprivation helps memory overall. It impairs it significantly. But it does illustrate how the timing and intensity of our sleep stages interact with dream recall in some very unexpected ways. The brain's visual cortex activates with incredible intensity during REM dreams. Neuroimaging studies show that the visual processing areas at the back of the brain light up during REM sleep almost as brightly as they do when we're awake and actually seeing the world. This is why our dreams are so profoundly visual, so filled with vivid images, colors, scenes, and movements. We aren't receiving any visual input from our eyes, which are closed, yet we experience a rich and compelling visual world. The brain generates all of this imagery internally. However, this intense visual activation doesn't automatically translate into visual memory. Seeing something in waking life activates both the visual cortex and our memory systems simultaneously. During dreams, the visual cortex fires intensely, but the memory systems aren't engaged in their normal encoding mode. We see elaborate dream imagery, but without the memory machinery running properly. These visions simply slip away. It's like watching a movie on a screen that has no ability to record what it displays. The temperature of our environment affects our sleep quality and, indirectly, influences our dream recall. The body's core temperature naturally drops during sleep, and this decrease is a necessary signal for entering deep, restorative sleep. If your sleeping environment is too warm or too cold, it can disrupt this process, causing brief awakenings or forcing you into lighter stages of sleep. These micro-arousals increase the chances of waking directly from or near a REM cycle, which in turn means more opportunities to remember your dreams. People who sleep in well-regulated, comfortable temperatures tend to sleep more deeply and continuously. They may have just as many dreams as those in a less stable environment, but they are less likely to remember them because they aren't waking up at precisely the right moments. It might seem like a trivial detail, but it perfectly illustrates how dream recall depends on a host of factors beyond the dream itself. The physical environment, our body's physiology, and the delicate timing of sleep stage transitions all play a role in determining which dreams we'll remember and which will fade into the forgotten vastness of the night. Alcohol consumption is known to severely impair dream recall. While a drink might help some people fall asleep faster, it fundamentally disrupts the natural architecture of sleep. In the first half of the night, alcohol actively suppresses REM sleep. Later, as the body metabolizes the alcohol, REM sleep often rebounds, sometimes producing unusually intense and vivid dreams. However, alcohol also fragments sleep and impairs the function of the hippocampus. So even when these intense REM periods do occur, the brain's memory encoding systems are working much less effectively under alcohol's influence. People who drink before bed often report either no dream recall at all or only fragmented, disturbing dream images. This happens because alcohol interferes with both the generation of normal REM sleep and the brain's ability to process and store the experiences that do manage to occur. The impairment extends beyond just dreams. Alcohol also affects the consolidation of memories from our waking experiences. But our dreams, already so fragile and difficult to capture, become even more ephemeral under its influence. Certain medications can dramatically alter both the content of our dreams and our ability to recall them. Antidepressants, particularly SSRIs, are well known for increasing dream vividness and recall, with some users reporting extremely vivid, bizarre, or emotionally intense dreams. This likely happens because these medications directly affect the neurotransmitter systems involved in regulating sleep and memory. Conversely, medications that block acetylcholine, such as some antihistamines or drugs for Parkinson's disease, can reduce REM sleep and therefore diminish dream recall. Beta blockers, often used for high blood pressure, can affect norepinephrine levels and also influence the dreaming process. In truth, any medication that crosses the blood-brain barrier and affects neural signaling has the potential to alter the delicate neurochemistry of sleep. Most of us don't consider how our medications might be changing our relationship with our dreams, but our inner nightlife is incredibly sensitive to these chemical influences. The same drugs that help with our physical or mental health during waking hours can quietly reshape the entire landscape of our sleep and dreams. The Dream Database, established by an international team in August 2025, represents a major advance in the scientific study of dreams. Coordinated by Monash University, with contributions from 37 institutions, including the Paris Brain Institute, this database centralizes EEG recordings and dream reports from over 500 participants, comprising more than 500 individual recordings. One of the database's primary goals is to help answer fundamental questions. Why do some people remember dreams every single night, while others rarely do? Why are we sometimes conscious during sleep and at other times completely unaware? This standardized, large-scale data allows researchers to compare brain activity patterns across different populations and conditions. This approach was desperately needed because individual dream studies typically have very small sample sizes. By pooling data, researchers can identify subtle but significant patterns that would be invisible in smaller studies. The dream database is designed to grow indefinitely, incorporating new findings as they emerge, and it may one day help us understand not just why we forget our dreams, but what dreams themselves are for. Dream content often weaves in our recent experiences, but it does so in highly transformed ways. This phenomenon, known as the day residue effect, reveals that fragments of our recent waking life frequently appear in our dreams, but almost never in a direct, one-to-one replay. Instead, the brain seems to remix these elements into novel and often bizarre combinations. You might dream about a person you saw briefly on the train, but they are combined with a location from your childhood, engaged in an activity from yesterday's work project. These strange concoctions may represent the brain's attempt to find new connections between recent experiences and its vast, existing memory networks. However, this very transformational process may also make the dreams harder to remember. When dream content is too far removed from our actual experiences, the waking mind struggles to recognize or categorize it. Our memories depend partly on having good retrieval cues, mental handles we can grab to pull the memory back into consciousness. But if a dream has been transformed beyond all recognition, those normal cues simply don't work. We lose the dream not because it wasn't vivid, but because we can no longer find the right mental pathway to retrieve it. Practice and intention are powerful tools for enhancing dream recall. People who diligently keep a dream journal, committing to the daily act of remembering, often find their ability to recall sharpens over time. This improvement stems from several interconnected mechanisms. The physical act of writing or typing out a dream reinforces the neural pathways associated with that specific memory. Furthermore, setting a clear intention before sleep, a simple mental note like, "Tonight, I will remember," my dreams activates metacognitive systems that can remain partially alert even during sleep. Those who genuinely value their dreams and reflect on them frequently develop more sophisticated mental schemas for categorizing and storing these unique experiences. As some researchers suggest, it's much like developing any other skill. Dream recall is an ability that can be trained and honed. The brain's inherent plasticity means that sustained attention can physically strengthen the neural networks responsible for capturing these fleeting narratives. However, it's crucial to remember that even the most skilled dream recallers forget the vast majority of their dreams. The brain's fundamental architecture during REM sleep imposes firm limits on what can be preserved. But within those limits, practice makes a profound difference. The mind learns to become more attentive to these ephemeral nighttime voyages. Let's pause here for a moment and turn your awareness inward. As you breathe out, long and slow, appreciate the universe of tiny cells within you. Trillions of organisms working in a silent, coordinated symphony. Your heart beating, your lungs breathing, your brain dreaming, all without a single command from you. Notice the gentle sensations on the surface of your skin, deep within your muscles, all along your spine. You are a complete and perfect ecosystem, infinitely diverse and naturally self-balancing. Your brain will process thousands upon thousands of dreams across your lifetime. Most will fade like mist, but their essential work remains. Organizing memories, processing emotions, and clearing away mental clutter. Trust in this profound, innate wisdom. Your mind knows what to hold onto and what to release into the ether. Now, let us continue. The precise timing of your awakening profoundly affects what you carry back from the world of dreams. Research consistently shows that waking up naturally, directly from a period of REM sleep, offers the best possible chance for rich dream recall. In stark contrast, the jarring summons of an alarm clock often rips us from whatever stage of sleep we're in, with no regard for the brain's delicate cycles. If an alarm yanks you out of deep, slow wave sleep, you're highly unlikely to remember any dreams, even if you had intensely vivid ones earlier in the night. Recognizing this, some modern sleep apps and devices now attempt to wake people during lighter stages of sleep, ideally near the natural conclusion of a REM period. These smart alarms can improve dream recall simply by respecting the brain's innate rhythms. The very act of waking shapes what we bring back from the night. An abrupt, startling awakening can flood the brain with stress hormones, effectively blasting away the delicate traces of a dream memory. A gentle, gradual awakening, however, allows for a much smoother transition, preserving the fragile tapestry of the night's experiences. The character of our dreams shifts dramatically as the night unfolds. Dreams that occur early in the night, during the first few REM periods, tend to be shorter, less emotionally charged, and more directly tied to the events of the preceding day. They are often reflections of the brain's initial sorting process. In contrast, the REM periods that occur closer to morning, after hours of memory consolidation have already taken place, tend to generate dreams that are longer, more bizarre, more emotionally saturated, and narratively complex. This pattern mirrors the brain's progressive work throughout the night. Early sleep is dominated by deep, slow-wave sleep, where the brain consolidates declarative memories. The brief REM periods that punctuate this phase often contain dream content that references this cognitive filing work. By morning, with that task largely complete, REM periods expand, and dreams blossom into more elaborate, surreal creations. While these late-morning dreams might seem more memorable due to their vividness, their proximity to full consciousness also makes them vulnerable. The neurochemical shift of waking can erase them just as thoroughly as their shorter, early night counterparts. The very language we use to frame our dreams profoundly shapes our ability to remember them. Cultures around the world vary widely in the importance they place on dreams and the vocabulary they have to discuss them. Some cultures possess a rich, detailed taxonomy for different types of dreams and their symbolic elements. Others tend to dismiss dreams as little more than meaningless neural static, These cultural frameworks have a direct impact on recall. People from cultures that value and actively discuss dreams consistently report remembering more of them, and their accounts are typically far more detailed. This is not simply a matter of reporting bias. The cultural expectation that dreams are meaningful and worthy of attention appears to actively enhance the brain's ability to encode them. Conversely, in cultures that dismiss dreams, individuals may literally forget them more quickly because there is no social or mental framework supporting their retention. Memory is inextricably linked to meaning. If an experience is perceived as significant, the brain's memory systems engage with full force. If it is deemed meaningless, it is quickly deprioritized and allowed to fade. The dream experiences of blind individuals offer fascinating insights into the nature of dream memory. People who lost their sight after the age of 5 or 6 typically continue to experience visual dreams, drawing upon a lifetime of stored visual memories. In contrast, those who were born blind or lost their sight very early in life report dreams devoid of visual content but rich with sound, touch, taste, smell, and emotion. Interestingly, studies show that blind individuals report dream recall at rates similar to sighted people. This powerful finding suggests that the visual component of a dream, while often the most striking feature for sighted individuals, is not essential for a dream to be memorable. What seems to matter more for recall are universal factors like emotional intensity, the coherence of the dream's narrative, and whether the person awakens at an opportune moment. The dreams of the blind remind us that dreams are not fundamentally about images, even though that's how most of us experience them. They are about the brain's incredible capacity to simulate experience, and their memorability hinges on general memory mechanisms, not on any specific sensory content. Slow-wave sleep plays an indirect but critical role in the process of dream forgetting. During this deepest stage of non-REM sleep, the brain exhibits large, synchronized waves of neural activity. It's a time for physical repair and, crucially, for memory consolidation. The neurotransmitter acetylcholine, vital for encoding new memories, drops to its lowest levels. This low acetylcholine state is ideal for transferring memories from the temporary storage of the hippocampus to the long-term archives of the cortex. While we don't typically have vivid, narrative dreams during this phase, the work accomplished here directly affects the REM sleep that follows. If slow-wave sleep is fragmented or disrupted, the subsequent REM periods can be altered, potentially impacting both dream content and the ability to recall it. The intricate dance between sleep stages means that the quality of dream memory depends not just on REM sleep itself, but on the integrity of the entire night's sleep architecture. Recurring dreams often stand out in our memory precisely because of their repetition. Some people experience the same dream narrative, or variations on a central theme, over and over for months, years, or even decades. These dreams are typically remembered with far greater clarity than unique, one-off dreams. Several factors contribute to this. First, repetition is a fundamental principle of memory. Each time the dream recurs, it reinforces the neural trace, making it stronger and more accessible. Second, recurring dreams often symbolize ongoing personal concerns, unresolved conflicts, or deep-seated anxieties, imbuing them with an emotional weight that anchors them firmly in memory. Third, as a person becomes aware that they are having a recurring dream, their attention to it sharpens, both within the dream itself and upon waking. This heightened attention more fully engages the brain's memory systems. Recurring dreams serve as a powerful demonstration that the brain's default mechanism for forgetting can be overcome when a dream carries sufficient significance or repeats often enough to become a recognizable feature of one's inner landscape. Pregnancy and the profound hormonal shifts that accompany it can dramatically alter both dream content and recall. Many pregnant individuals, particularly in the third trimester, report a significant increase in dream vividness and a much improved ability to remember their dreams. This phenomenon is likely tied to several factors. Physically, pregnancy often leads to more frequent nighttime awakenings, which provide more opportunities to catch a dream in the fragile moments before it fades. Biologically, dramatic shifts in hormones, like progesterone, directly influence sleep architecture and the neurotransmitter systems involved in memory. Psychologically, the immense significance of pregnancy can make dreams feel more meaningful and urgent, prompting more focused attention upon waking. Conversely, after childbirth, many report a period of diminished dream recall, likely due to severe sleep disruption and exhaustion. This natural experiment beautifully illustrates the delicate and reactive nature of dream memory. When our biology and sleep patterns shift, our relationship with the dream world shifts right along with them. The brainstem's role as the engine of REM sleep indirectly influences dream memory. A specific region called the pons acts as the primary switch, initiating REM by sending signals that paralyze the body's major muscles while simultaneously activating the cerebral cortex. While this process is essential for creating the state in which we dream, the signals themselves contain no instructions to remember the resulting experience. From an evolutionary perspective, REM sleep likely developed for functions like neural development, synaptic pruning, and memory consolidation, not specifically to produce conscious narratives for our later enjoyment. Dreams may be an emergent, almost accidental byproduct of this vital underlying process. If dreams are essentially a side effect, it makes perfect sense that the brain wouldn't have a default system for preserving them. The unique neurochemical cocktail that generates dreams is optimized for processing times, existing times, memories, not for creating and storing times, new times, episodic memories of the dreams themselves. The strange feeling of déjà rêvé, or already dreamed, hints at the existence of hidden dream memories. Distinct from the more common déjà vu, the feeling of having lived a moment before, déjà rêvé is the specific sensation that a current waking experience was foretold in a dream. What's puzzling is that the person experiencing it can rarely, if ever, recall the specific dream in question. One compelling explanation is that we store far more dream content than we can consciously access. These memories may exist below the threshold of conscious recall, but can still be triggered by a similar waking event, generating a powerful feeling of familiarity. This suggests that dream forgetting isn't an absolute erasure, but rather a profound failure of retrieval. The memories aren't gone. They're simply filed away in an inaccessible part of the mind, capable of surfacing only as vague feelings rather than clear recollections. This possibility points toward a vast, submerged reservoir of dream experiences that subtly shapes our mental life, entirely without our awareness. Narcolepsy, a neurological disorder characterized by dysregulated REM sleep, offers a unique window into dream memory. Individuals with narcolepsy can enter REM sleep directly from a state of wakefulness, bypassing the normal sleep stages. They often experience vivid, bizarre hypnagogic hallucinations, essentially waking dreams as they fall asleep or wake up. Many people with narcolepsy report exceptionally good dream recall, likely because their REM periods frequently intrude into wakefulness, and they awaken directly from dreams far more often. The disorder effectively blurs the boundary between waking and dreaming, and in doing so, it makes the dream experience far more memorable. For most people, this boundary is sharp and well-defined, and the transition across it erases the dream. For those with narcolepsy, the blurred boundary allows the dream to be preserved. While this is a source of significant impairment, it powerfully demonstrates that our normal process of dream forgetting relies on maintaining a clear neurochemical separation between our sleeping and waking worlds. Our dreams can incorporate external stimuli from our environment, yet we typically don't remember these dreams any better than others. Research has shown that sounds, lights, physical touch, or even smells can be seamlessly woven into a dream's narrative without waking the sleeper. The sound of a ringing telephone might become a fire alarm in the dream. A spray of water on the face might become a sudden rainstorm. Despite this direct link between external reality and dream content, these stimulus-influenced dreams are not usually more memorable than purely internally generated ones. The incorporation happens unconsciously. The sleeping brain is a masterful improviser, weaving outside information into its ongoing story without ever engaging the specific memory systems that would flag the experience for later recall. This shows that the problem of dream forgetting isn't about the dreams lacking substance or being less real than waking experiences. Even dreams that directly respond to actual sensory input are subject to the same rapid fading. The issue isn't what happens times in times the dream. It's what times doesn't times happen in the brain's memory centers during REM sleep. The practice of dream incubation, the conscious attempt to cultivate specific dream content, can sometimes lead to improved recall. Before falling asleep, an individual might focus their thoughts on a problem they wish to solve, a place they want to visit, or a person they hope to see in their dreams. Studies have shown this technique can successfully influence the content of dreams. Interestingly, when people succeed in incubating a dream, they often report better than average recall of it. This may be because the pre-sleep intention and focus act as a primer for the brain's memory systems. By deliberately thinking about the desired dream, you are essentially creating retrieval cues in advance. When the related dream content appears, these pre-established mental hooks may help the experience stick more firmly in memory. It's akin to telling your brain, "Pay attention to this." While this effect is real, it is modest. Dream incubation doesn't dismantle the fundamental neurochemical barriers to dream memory. It simply provides a slight advantage for working more effectively within them. Episodes of sleep paralysis are remembered with terrifying clarity, and in doing so, they reveal what makes regular dreams so forgettable. Sleep paralysis occurs when the mind wakes up before the body. The muscle atonia of REM sleep hasn't yet worn off, leaving the person consciously aware but temporarily unable to move. These episodes are often accompanied by frightening hallucinations, such as sensing a malevolent presence or feeling a heavy pressure on the chest. Unlike fleeting dreams, these experiences are seared into memory. This is because the person is for all intents and purposes, awake. Their waking neurochemistry, including the systems for memory encoding, is fully online. The experience bridges the gap between a REM-like brain state and full waking consciousness. This stark contrast perfectly highlights why regular dreams fade. During normal REM sleep, we lack that crucial element of conscious awareness and the memory encoding machinery it commands. Sleep paralysis is memorable precisely because it bypasses the normal forgetting mechanisms. The sleeping brain's distorted sense of time creates significant challenges for dream memory. Time perception during a dream is notoriously fluid and unreliable. A dream narrative that feels as if it spanned several hours might take place in just a few minutes of real-time REM sleep, while a fleeting instant in a dream can feel subjectively stretched and prolonged. This temporal distortion is a major obstacle for our waking memory systems, which rely heavily on linear sequence and temporal context to organize experiences. Dreams lack these reliable temporal signposts. Events blur into one another. Cause and effect become muddled, and chronological order is often scrambled. When we awaken and try to recall a dream, we are attempting to impose our waking sense of linear time onto an experience that operated under entirely different rules. This fundamental mismatch makes the dream narrative difficult to grasp and hold on to. It's like trying to draw a map of a place where the landscape itself was constantly shifting. Emerging technology is beginning to allow researchers to decode dream content directly from brain activity. In several groundbreaking studies, scientists have used machine learning algorithms to analyze fMRI or EEG data and predict the general category of what a person was dreaming about. For instance, whether they were seeing a face or a car. This process requires waking participants repeatedly from REM sleep, asking for a dream report, and then correlating that report with the brain activity recorded just before awakening. While the accuracy is still limited and requires extensive training of the algorithm for each individual, it demonstrates a profound point. Our dream content leaves a distinct, traceable signature in our neural activity. These patterns exist even if the dreamer has no conscious memory of them. This raises a fascinating possibility. Perhaps our forgotten dreams are not erased, but are stored in a format our conscious mind simply cannot access. Future technology might one day allow us to read these lost memories. Or, perhaps, these patterns are merely the fading echoes of neural activity, dissipating moments after they occur. Either way, the research confirms that something of our dreams persists, at least for a while, whether we remember it or not. If you are still here with me, your thoughts still flickering like the flame of a candle, just notice them. Don't judge. Simply observe where your mind is at this moment. We are exploring the very nature of consciousness, using the very tool that we are exploring. It is a strange, beautiful, and perfectly calm paradox. Let us drift onward together. The evolutionary purpose of dreaming remains one of neuroscience's great unsolved mysteries, and how we view this question colors our understanding of dream forgetting. Some theories propose that dreams served as a virtual reality simulator for our ancestors, allowing them to practice threat responses in a safe environment. If this is the case, the experience itself would be more important than the memory of it. Other researchers argue that dreams are simply meaningless neural noise, an accidental byproduct of the brain's nightly maintenance. If so, there would be no evolutionary pressure to develop mechanisms for remembering them. A third school of thought suggests dreams are essential for integrating memories and processing emotions. In this view, the forgetting might be a deliberate feature, not a bug, a way of clearing the cognitive workspace once the processing is complete. Just as your liver detoxifies your blood without sending you a detailed report, your dreaming brain may be doing its work without needing to create a lasting record. In almost every major theory, the ease with which we forget our dreams suggests they were not designed to be remembered. Musical dreams can be exceptionally vivid and emotionally potent, yet they are still subject to the same rapid fading. Some people dream of hearing music, sometimes familiar pieces, other times entirely new and original compositions. Unsurprisingly, musicians report these experiences more frequently than non-musicians. During these dreams, the brain's auditory cortex shows heightened activity, and the experience can feel as real and immersive as attending a live concert. Yet even these uniquely powerful and structured dreams typically evaporate upon waking. On rare occasions, a dreamer like Paul McCartney with the song "Yesterday Wakes Up" and manages to capture the melody before it's gone. But far more often, the music is lost forever. This demonstrates that the specific type of dream content doesn't override the fundamental forgetting mechanism. It matters less times what times we dream about, be it beautiful music, a complex narrative, or a profound insight, and more that it occurs in the unique brain state that is simply not optimized for making memories. Nightmares, by their very nature, tend to be remembered far more readily than pleasant or neutral dreams. The amygdala, the brain's fear and emotion processing center, is highly active during REM sleep. A nightmare supercharges this activity, and the intense fear it generates often causes a partial or full awakening. This powerful combination, strong emotion plus an abrupt awakening, is a potent recipe for memory encoding. From an evolutionary standpoint, this makes perfect sense. An ancestor who vividly remembered a dream about being attacked by a predator might have been more vigilant the next day. The memorability of nightmares, while distressing, may have once been an adaptive trait. Today, chronic nightmares can be a symptom of disorders like PTSD, but the underlying principle remains. Emotionally salient experiences are more likely to cut through the fog of sleep and leave a lasting mark. Fear is a powerful anchor for memory. Dream reports show a steep and rapid decay in detail from the moment of awakening. Studies that involve waking participants directly from REM sleep find that if asked for a report immediately, people can often provide long, elaborate, and detailed narratives. If the researcher waits just 5 minutes, the report becomes significantly shorter and more fragmented. After 15 minutes, large sections of the dream have vanished entirely. An hour later, most people can recall only a few disconnected images or nothing at all. This sharp decay curve suggests that dream memories exist briefly in a very fragile, temporary buffer, similar to short-term working memory. They never fully make the transition into stable, long-term storage unless an active effort is made to preserve them by writing them down, telling someone about them, or rehearsing them mentally. Otherwise, they simply degrade and dissolve. The phenomenon of a false awakening highlights the complex interplay between consciousness and memory during sleep. A false awakening is a dream in which you believe you have woken up. You might dream of getting out of bed, walking around your own room, and starting your morning routine, only to then times wake up and realize the previous experience was entirely a dream. These events can be deeply disorienting but are often remembered with unusual clarity. This may be because, in simulating the act of waking, the brain temporarily activates some of the same neural patterns it uses in genuine wakefulness, including more robust memory encoding. False awakenings demonstrate that the dreaming brain is capable of producing states that closely mimic waking consciousness. And when it does, the resulting experience becomes more memorable. This supports the idea that normal dream forgetting is a direct consequence of the unique neurochemical state of REM sleep. The moment that state shifts, even slightly, toward a waking pattern, memory improves. Some people claim they never dream, but laboratory research shows this is almost certainly not the case. Sleep studies confirm that virtually everyone with a neurologically typical brain enters REM sleep multiple times per night. When these self-proclaimed non-dreamers are awakened at the right moment during a REM cycle, they can almost always provide a dream report. What they really mean is that they never remember their dreams spontaneously upon waking. This extreme level of dream forgetting could be related to a variety of factors, such as how deeply they sleep, the nature of their brain's transition from sleep to wakefulness, or simply a lack of attention paid to their inner world. Some individuals may have a particularly efficient barrier between their sleeping and waking consciousness, preventing dream memories from crossing over. This isn't inherently better or worse than having high recall. It's just a different cognitive style. But it powerfully illustrates that dream forgetting exists on a spectrum, from those who forget everything instantly to those who retain memories of multiple dreams every night. Our sense of self can become fluid, distorted, or even absent in dreams, which profoundly affects our ability to remember them. In waking life, our stable, the continuous sense of being the same person from one moment to the next provides a crucial framework for autobiographical memory. We remember events as things that happen to us in dreams. However, this anchor of self is often unstable. You might be yourself, but at a different age. Or you might be an observer watching your own actions from a third-person perspective. This fragmentation of the self creates a major challenge for memory consolidation. When you awaken, your unified waking self returns. But the dream was experienced by a slightly different entity. The waking you may struggle to claim ownership of the dream self's experiences, making it difficult to integrate them into your personal life story. This discontinuity makes the dream feel alien and hard to grasp, as if it happened to someone else. The social act of sharing dreams within relationships and families can significantly strengthen dream memory. When people make it a regular practice to tell their dreams to a partner, friend, or family member, it sets off a positive feedback loop. First, the act of verbalizing the dream forces the brain to structure the narrative, reinforcing the memory and helping it to endure. Second, the social interest from others provides a powerful motivation to pay attention and remember dreams in the first place. If you know someone will ask about your dreams in the morning, you're more likely to try to catch one as you wake. Finally, the listener's questions and reactions can help elaborate the memory, prompting the recall of details that might otherwise have been lost. In cultures or family units where dream sharing is a common practice, overall dream recall tends to be higher. This highlights a crucial aspect of memory. It is not a purely individual process. we remember better what our communities deem valuable. Specific types of brain injuries can eliminate dreaming altogether or selectively impair only the recall of dreams. Damage to a key junction, where the parietal, temporal, and occipital lobes meet, can result in a condition where patients completely stop reporting dreams. When awakened from REM sleep, they describe only abstract thoughts or nothing at all, suggesting this brain region is critical for generating the vivid, immersive experiences we call dreams. Conversely, damage to other areas, particularly in the prefrontal cortex, can leave the ability to dream intact while severely impairing memory. These patients report having rich, vivid dreams but forget them even more rapidly than the average person. These clinical cases provide clear evidence that the system for times creating times dreams is neurologically distinct from the system for times remembering times them. One can exist without the other. This separation helps explain the everyday experience of forgetting. For all of us, the memory systems are simply under-engaged and disconnected during the dream state. Dreams can embody abstract thoughts and concepts, not just visual imagery. While we typically imagine dreams as cinematic features playing out in our minds, their content often includes complex reasoning, problem-solving, conceptual breakthroughs, and non-sensory information. You might, for instance, dream of grasping a complex scientific theory without any corresponding visual representation. These abstract dreams are particularly difficult to recall because they lack the concrete sensory details that typically anchor our memories. A vivid visual scene provides retrieval cues. The image itself helps you remember it. But a pure, abstract understanding or a simple feeling of times, knowing times, something doesn't leave the same indelible hooks in our memory. Upon waking, you might retain a lingering sense that you understood something profound, but the specific insight itself has evaporated, leaving only a frustrating echo. This is a common lament for people who feel they've solved major problems or gained life-altering insights in their sleep. The solution was there, briefly, but the brain's waking memory systems had nothing tangible or physical to grab onto to preserve it. We have traveled halfway, and in this moment, let each breath guide you to a simple realization. Time is yours, a separate stream that only you are living, while consciousness continues its endless flow to dream, to forget, to remember this single second. The one in which you are breathing and listening is utterly unique. Your dreams may fade with each morning's light, but this is not a loss. It is the mind refreshing itself, clearing the slate for new experience. Cherish this present moment, knowing that right now, your awareness is a singular phenomenon in the universe. And so, we continue drifting. The phenomenon of prospective dreaming suggests that some dream memories, against all odds, do persist. These are instances where people report dreams that seem to anticipate or foreshadow future events. While the vast majority of these are attributable to coincidence or the reconstructive nature of memory, they hint that dreams can occasionally leave a lasting impression. When a dream happens to later align with a real-world experience, the emotional impact of the coincidence makes it intensely memorable. This powerful selective memory effect creates the illusion that prophetic dreams are common. In reality, we forget the thousands of mundane dreams that never corresponded to anything. But the rare few that seem to connect to the future are remembered precisely times, because times of that powerful connection demonstrating how motivation and perceived meaning can fortify even the most fragile of memories. The default mode network's activity during REM sleep may, paradoxically, to be a key facilitator of forgetting. This brain network is typically involved in self-referential thought and memory consolidation during our waking hours. During REM sleep, however, it exhibits fundamentally altered patterns of connectivity. Some researchers propose that these patterns reflect the brain actively reorganizing memories. In this process, the specific narrative of the dream is discarded as its underlying emotional or cognitive purpose is integrated. The dream, in this view, is the times processing asterisk, not the final product. Once the processing is complete, the dream itself becomes unnecessary and is allowed to fade. Like scaffolding used to erect a building and then taken down, dreams support the essential work of memory consolidation, but are not intended to become part of the permanent structure themselves. Sensory deprivation can dramatically intensify dreams and, in some cases, improve their recall. Individuals who spend time in isolation tanks or quiet retreat environments frequently report more vivid dreams and a clearer memory of them upon waking. With drastically reduced external stimulation, the brain may become more attuned to its own internal experiences, allowing dreams to stand out more sharply against a silent backdrop. Furthermore, people in such retreat settings have fewer new experiences competing for memory space. Without the constant influx of waking information, dream memories face less interference and may persist for longer. This suggests that the sensory overload of modern life may be a significant contributor to our collective dream amnesia. Our brains are simply too busy processing the day to hold on to the night. Children's nightmares and night terrors differ profoundly in their memorability, highlighting the role of sleep stages in memory formation. Night terrors erupt during deep, slow-wave sleep, not REM. A child in the grip of a night terror may appear awake and terrified, but they are sound asleep and will typically have no memory of the episode the next morning. Nightmares, in contrast, occur during REM sleep and are often remembered, at least in fragments. This distinction is a clear illustration of how memory encoding is state-dependent. Night terrors happen in a physiological state that is almost completely hostile to memory formation. Nightmares occur during REM, which allows for some memory encoding, especially if the fear is intense enough to jolt the child awake. The emotional salience of a nightmare helps it stick, demonstrating the powerful principle that emotion enhances recall. Even for dreams, the practice of meditation can have a marked influence on both dream recall and lucidity. Individuals who meditate regularly, particularly those engaged in practices that cultivate present moment awareness, often report enhanced dream recall and an increased frequency of lucid dreaming. Meditation may strengthen metacognitive skills, the ability to observe one's own mental states from a detached perspective. This skill, honed during waking hours, can carry over into the sleep state. A mind trained to notice the flow of its own thoughts is more likely to notice when it has entered the state of dreaming. Additionally, meditation can alter sleep architecture and neurotransmitter systems, potentially creating neurological conditions more favorable for dream memory. The relationship is complex, but it clearly demonstrates that mental training can extend its influence into the ephemeral realm of dream experience. Color perception in dreams varies widely from person to person. Some people dream in brilliant, vivid color, others in muted tones, and a small percentage consistently report dreaming in black and white. Interestingly, research has shown that individuals who grew up watching black and white television are more likely to have monochromatic dreams. This suggests that our dreams draw heavily upon our library of lived experiences and media consumption, regardless of the color palette. However, dream recall doesn't seem to be significantly affected. A full-color dream is not inherently more memorable than a black and white one. What matters far more are factors like emotional intensity, narrative coherence, and the timing of awakening. This reveals that while specific sensory qualities can make a dream feel more or less vivid in the moment, they aren't the primary drivers of whether it will be remembered. Dream content is rich with cultural and personal symbolism, but the act of interpretation doesn't necessarily improve memory. Humans have always sought to find meaning in dreams. From the elaborate interpretive systems of ancient civilizations to modern psychology's exploration of the unconscious. However, actively analyzing a dream doesn't reliably help you remember it better. In fact, forcing an interpretation can sometimes interfere with pure recall, as the analytical process activates different brain systems than those used for simple memory retrieval. Some people find that trying too hard to understand a dream's meaning actually makes the memory of it slip away faster. The significance of a dream, if any, exists independently from the memory of it. It is entirely possible to have a profoundly meaningful dream and forget it completely, or to perfectly remember a dream that was utterly meaningless. The transition from REM sleep to wakefulness involves a rapid cascade of neurochemical changes that effectively wipe the slate clean. Within seconds of waking, multiple neurotransmitter systems shift gears dramatically. This abrupt transition likely serves a crucial protective purpose. It prevents the bizarre logic and imagery of the dream world from bleeding into waking cognition. If dream memories persisted too strongly, we might struggle to distinguish real experiences from imagined ones. This forgetting mechanism is what protects our ability to navigate reality. In pathological conditions where this boundary blurs, such as in some forms of psychosis or severe sleep disorders, the resulting confusion can be deeply disorienting. Normal dream forgetting, then, isn't a bug. It's a feature designed to maintain a clear and vital boundary between different states of consciousness. A dream can sometimes be resumed if it is only briefly interrupted. If you wake up midway through a dream and manage to fall back asleep quickly, you may find that the dream's narrative picks up right where it left off. This suggests that the dream exists as an ongoing neural pattern that can be reactivated. However, even when a dream continues, memory of it rarely improves. The brief moment of waking provides an opportunity to capture the dream, but most people are too groggy to consciously do so. By the time they fully awaken later, both segments of the dream have often faded. This illustrates just how fragile dream memory is, even with multiple chances to be remembered. The brain's fundamental forgetting mechanism continues its work. Age affects dream content and recall in complex ways. Young adults typically report more vivid dreams and have better recall than the elderly, a shift that may be linked to changes in sleep architecture over a lifetime. Older adults spend less time in REM sleep, and their REM periods may be less intense, producing less vibrant dreamscapes. Furthermore, age-related changes in waking memory systems also impact dream recall. The same neurological processes that can make it harder to form new memories during the day also make it more difficult to retain dreams from the night. Interestingly, however, some older adults report that dreams from their youth remain surprisingly vivid in their memory, suggesting that the dreams from early life that do manage to be encoded can persist for decades. The phenomena of hypnagogic and hypnopompic hallucinations exist on the very border between waking and dreaming. Hypnagogic experiences occur as you are falling asleep, while hypnopompic experiences happen as you are waking up. Both can include vivid images, sounds, or bodily sensations. Because they occur during these transitional states rather than in deep sleep, they are often remembered with far greater clarity than typical dreams. During these moments, the brain is in a hybrid state, partly awake and partly asleep, so memory systems are more engaged than they are during full REM sleep. These experiences demonstrate a clear principle. The closer a dreamlike state is to waking consciousness, the more memorable it becomes. True dreams, occurring deep within a solid REM cycle, are the furthest from waking and therefore the most forgettable. Dreaming about a skill you are learning can sometimes lead to improved performance, even if the dreams themselves are forgotten. Studies have shown that people who dream about tasks they are practicing, such as navigating a virtual maze or playing a musical instrument, often perform better on that task after sleeping. The dream content appears to be a conscious reflection of unconscious memory consolidation. Crucially, however, the participants often have no specific memory of the dreams in which they practiced. The skill improvement happens whether they consciously recall the dreams or not, demonstrating that dreams can serve critical functions well below the level of conscious awareness. The work gets done and the benefit is gained, but the experiential record of that work remains ephemeral. The language and verbal content in dreams can be surprisingly sophisticated, yet this is often the first thing we lose. People report having complex, articulate conversations in their dreams, sometimes even in languages they barely know when awake. The dreaming brain seems capable of generating fluent speech and comprehension. Upon waking, however, the specific words almost always vanish. You might remember that you had a conversation, who you spoke with, and even the general topic, but the actual dialogue is gone. This is similar to how we forget the precise wording of waking conversations while retaining the gist. But with dreams, the loss is far more complete and immediate. Physical movement is suppressed during dreams, but the intention to move remains fully active. During REM sleep, the brainstem sends signals that paralyze most of the body's voluntary muscles, a protective mechanism known as REM atonia. This prevents us from physically acting out our dreams. Yet, the motor cortex is still firing, generating the commands for movement. In your dream, you might be running, fighting, or dancing, and your brain creates the full sensation of that movement even as your body lies still. This profound disconnect may contribute to dream forgetting. Waking memories are often tied to proprioceptive information, the physical sense of our body's position and movement in space. Dreams lack this physical anchor. When you wake, the discrepancy between the dream's grand adventures and your body's static reality may make the dream harder to integrate into your personal history. The idea of shared or collective dreaming, while a fascinating concept, likely reflects coincidence and false memory rather than a genuine shared experience. Occasionally, friends or family members report having dreams with similar themes on the same night. These accounts are intriguing but rare, and the similarities are usually quite vague. It is more probable that people unconsciously shape their memory of a dream to align with another person's report after the fact. Memory is a reconstructive process, not a perfect recording. Hearing someone else's dream can subtly alter your own recollection of yours. This malleability demonstrates just how unstable dream memories are. They are not fixed facts, but mutable narratives, susceptible to suggestion, expectation, and social context. Animals also appear to dream, and studying them offers clues about dream function. Dogs can be seen twitching their paws and whimpering in their sleep, strongly suggesting they are dreaming. In laboratory settings, rats exhibit brain activity patterns during sleep that perfectly mirror the patterns recorded when they were running a maze earlier that day. Since animals cannot report their dreams, we can't know if they remember them in any human sense. But this research suggests that whatever dreaming accomplishes, it likely does not require conscious awareness or explicit memory of the experience. The benefits of dreaming, the reorganization of neural connections, and the consolidation of learning happen at a fundamental biological level. The subjective story we experience may just be a side effect of that essential, unconscious work. Dream diaries can become remarkably detailed archives, yet they are filled with entries describing dreams that would have otherwise been completely forgotten. People who consistently keep a dream journal can amass a collection of hundreds or even thousands of dreams. When reading back through old entries, they often encounter detailed accounts of dreams they have absolutely no independent memory of. This shows that the act of writing down a dream does not guarantee its long-term storage in your biological memory. The journal serves as a form of external storage for experiences your brain has chosen not to preserve. This act of externalizing memory highlights a key truth. While the mind is designed to let dreams go, we can choose to intervene and save them. The emotional intensity of a dream does not always correlate with its memorability. You can have a dream that feels overwhelmingly powerful in the moment, filled with terror or ecstasy, yet forget it completely by morning. Conversely, a bland, emotionally neutral dream might stick with you for days for no apparent reason. While strong emotion generally acts as a memory enhancer, the relationship isn't absolute for dreams. A host of other factors are at play. The timing of your awakening, the specific sleep stage, overall sleep quality, stress levels, and simple chance. Sometimes a dream memory survives, not because it was particularly significant, but because a random confluence of factors activated the right neural pathways at the right moment. This unpredictability is part of what makes dream forgetting feel so arbitrary. Lucid dreamers can sometimes conduct experiments within their dreams and remember the results afterward. In a lucid dream, the dreamer becomes aware that they are dreaming and can sometimes exert conscious control. They might perform pre-planned tasks, like attempting to read text or alter the dream environment. A recent multi-lab study showed that during lucid dreams, brain regions associated with self-awareness and executive function become more active than in typical dreams. This heightened awareness appears to engage memory systems more effectively. As a result, lucid dreamers often report better recall not just of their lucid dreams, but of their non-lucid dreams as well. The practice of becoming lucid may train the brain to maintain greater continuity between sleeping and waking consciousness. lowering the barrier that normally causes dream forgetting. Dreams that occur during daytime naps are often forgotten even more readily than those at night. Nap dreams tend to be shorter and occur during lighter, less consolidated REM periods. Additionally, the transition from a nap to wakefulness is usually abrupt, with the person moving directly into daily activities. There is no gentle, gradual awakening period that might allow dream memories to stabilize. Furthermore, most people don't expect or place value on dreams from a nap, so they pay them less attention. This demonstrates how our context and expectations shape recall. Nighttime sleep is culturally framed as the proper time for dreaming. Naps are seen as brief periods of rest. This framing alone influences whether we even notice, let alone remember, the dreams that occur within them. The sleeping brain exhibits patterns of neural activity that mirror waking experiences, a process of replay that doesn't require conscious awareness. Researchers can detect when a sleeping rat's brain is reprocessing memories of running a maze, as the hippocampus replays the exact sequences of neural firing. This is believed to be the core mechanism of memory consolidation. Our conscious dreams may simply be the narratives our minds weave around this underlying process of memory replay. But the crucial work of consolidation happens whether we experience a corresponding dream or not, and whether we remember it or not. The conscious dream may be an epiphenomenon, a story our awareness tells itself, while the real work happens silently, deep beneath the surface. Certain natural supplements and herbs are popularly claimed to enhance dream recall, though scientific support remains mixed. Vitamin B6, galantamine, and mugwort are frequently mentioned in this context. Some limited studies suggest these substances can affect sleep architecture or neurotransmitter systems in ways that might influence dreaming. However, the evidence is largely anecdotal and inconsistent. What is clear is that any times substance that affects sleep, including caffeine, alcohol, and prescription medications, has the potential to affect dreams. The brain's neurochemistry during sleep is a delicate balance, and anything that alters it can create ripples that affect both dream generation and memory. To date, however, no supplement has been proven to be a reliable dream recall aid for everyone. Some dream researchers endorse the threat simulation theory, which proposes that dreams evolve to help us prepare for real-world dangers. According to this hypothesis, dreams are so often filled with threatening scenarios: being chased, falling, failing a test, because rehearsing our responses to these threats in the safety of sleep enhances our survival instincts when we're awake. If this theory is correct, then the dreams themselves don't need to be remembered for the training to be effective. The neural pathways activated during the dream would be strengthened, improving our instinctual response patterns regardless of conscious recall. This would elegantly explain why we have evolved to forget most dreams. The practice effect is unconscious. Remembering the specific drills would be unnecessary and potentially distracting. The link between dreams and creativity is undeniable, but it doesn't depend on direct memory. Many artists, scientists, and inventors report that crucial ideas came to them in dreams. Yet for every remembered breakthrough dream, there are likely dozens of forgotten ones that nonetheless influenced their creative thinking. Dreams can prime the creative process by loosening associations and allowing for novel combinations of ideas to emerge. These beneficial effects can persist into waking life even after the specific dream that sparked them is forgotten. You might wake up with a fresh perspective or an elegant solution to a problem without remembering the dream that delivered it. The creative work happens during sleep. The conscious mind only needs access to the results, not a record of the process. Following a traumatic event, nightmares can become intrusive and agonizingly difficult to forget, representing a catastrophic breakdown of the normal dream-forgetting mechanism. In post-traumatic stress disorder, PTSD, nightmares often replay the disturbing event or variations of it with painful clarity. These dreams are remembered with such intensity that they can be hard to distinguish from memories of the actual trauma. This demonstrates that when the brain's fear center, the amygdala, becomes chronically hyperactive and the regulatory control of the prefrontal cortex is weakened. These fear-based dreams can bypass the usual barriers and permanently inscribe themselves in memory. This pathological persistence of dream memories is a source of immense suffering, and it serves as a stark reminder that normal dream forgetting is, in fact, a deeply protective and necessary function. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the natural cycles. Your mind cycles through waking and sleeping, through remembering and forgetting, through vivid dreams and dreamless rest. All of these states are natural. All are necessary. Like your breath, inhale, exhale, inhale, exhale, a small, perfect cycle within the vast universe of consciousness. You don't need to hold on to anything. You don't need to remember everything. Simply let it all unfold in its perfect order, like thoughts arising and fading during meditation. Unhurried, unresisting, simply existing. We're almost there now. Every single person dreams multiple times each night, even those who are adamant they never dream. The universality of dreaming across all cultures and all healthy human beings strongly suggests it serves vital biological functions. Yet, the near-universal phenomenon of dream forgetting just as strongly suggests that conscious recall is not one of those functions. Dreams do their work silently, in the background of consciousness, much like countless other essential brain processes. Your heart beats, your liver processes toxins, and your immune system fights infections, all without your direct awareness. Dreams may belong to this same category of vital, autonomous processes that operate best without the interference of our conscious attention. The feeling of times having dreamed asterisk, even without any specific memory of the dream's content, may itself be meaningful. Some mornings you simply wake up with the distinct sensation that you were dreaming, even though no images or narratives remain. This feeling might carry its own subtle information, a sense of whether the dreams were pleasant or disturbing, emotional or neutral. The explicit memory is gone, but an impression persists, coloring our waking mood in subtle ways. This suggests that dreams influence us even when we can't remember them consciously, contributing to how we feel without our ever knowing why. Forgetting our dreams allows each night and each new day to start fresh. If we remembered every dream with perfect clarity, our minds would become cluttered with thousands of vivid experiences that never actually happened. We might find it increasingly difficult to distinguish real memories from dream imagery. The act of forgetting creates a clean, necessary boundary. Waking life is real, dreams are ephemeral. This separation protects our grasp on reality and allows sleep to be truly restorative, a time when the mind can play, process, and explore freely, without lasting consequences or intrusions on waking life. Some philosophers argue that the inherent transience of dreams is a powerful reflection of the transience of all experience. Nothing lasts. Thoughts come and go. Emotions rise and fall. And even the cells in our bodies are constantly being replaced. Dreams simply make this universal impermanence more obvious. They are so brief, so fragile, that they highlight a fundamental truth about all of our experiences. They are fleeting. By recognizing that we cannot hold on to our dreams, perhaps we can learn to hold on to everything else more lightly, to appreciate each moment of experience without desperately clinging to it. The dreams we actually do remember might not be representative of our overall dream life. It's plausible that we only remember the most bizarre, the most emotionally charged, or the ones that happen to occur just moments before our alarm goes off. The vast majority of our dreams, the ordinary, quiet, mundane ones may slip away, completely unnoticed. This means that when we think about our dreams, we are really only thinking about a highly curated selection, not the complete collection. We are seeing the highlight reel, not the full archive. Our conscious understanding of our own dream life is, therefore, necessarily incomplete and possibly quite distorted. The very act of writing down a dream can fundamentally change your memory of it, translating a rich, multi-sensory experience into the limited medium of words inevitably reshapes it. Language requires you to simplify, to linearize, and to make the illogical fit the constraints of grammar. Later, you may remember the written version more clearly than the actual dream you experienced. Your dream journal then becomes not just a record, but a transformation, a translation of one form of experience into another. The original is still forgotten, replaced by this more stable, linguistic version. Newborn infants spend approximately 50% of their sleep time in the REM stage, a proportion that gradually decreases to about 25% by adulthood. This enormous amount of REM sleep is thought to be critical for supporting rapid brain development, helping to organize the trillions of newly forming neural connections. The dreaming that must occur during all this REM time presumably serves this developmental purpose. But infants cannot tell us what they dream of, and they almost certainly don't remember any of it. This shows that dreaming, in its most abundant and perhaps most crucial form, occurs entirely without memory, without language, and without any capacity for later recall. The essential work of dreams happens in darkness and in silence. Occasionally, a dream memory will surface unexpectedly, hours or even days after you've woken up. A particular smell, a passing sight, or a snippet of conversation might suddenly trigger the return of a dream you had completely forgotten. These rare moments of spontaneous recall show that some dream memories do persist in a hidden, latent form, waiting for precisely the right cue to be reactivated. But these instances are unpredictable and cannot be summoned deliberately. You can't actively search your memory for a forgotten dream. This suggests that dream memories are stored in a different format than normal memories, one that is not readily accessible to our conscious retrieval processes. People who experience lucid dreams more frequently sometimes report feeling tired during the day, suggesting that heightened awareness during sleep may diminish its restorative quality. This points to a potential trade-off between vivid dream recall and high-quality sleep. The very mechanisms that would allow us to remember our dreams in sharp detail might interfere with sleep's primary directives: rest and restoration. In this light, our normal habit of dream forgetting might be the price we pay for truly regenerative sleep. Too much awareness. Even the self-awareness found in a lucid dream may ultimately defeat sleep's most essential purpose. The experience of a dream is profoundly private and, ultimately, inexpressible. No one can ever truly know what it is like to be inside another person's dream. Even the most detailed descriptions fall short, as dreams fundamentally resist language. They exist in a realm beyond words, a tapestry woven from fleeting sensations, impossible perspectives, and emotional tones that have no name. This inherent ineffability is a major contributor to our forgetting. If an experience cannot be properly encoded in language or other symbolic systems, our memory has a difficult time holding on to it. Dreams slip through our fingers, in part because we simply lack the proper tools to capture and preserve them. Some dream content may simply reflect the random firing of neurons, carrying no deeper meaning. Not every dream is a symbol waiting to be interpreted. Some dreams might just be noise, the brain keeping its circuits active during sleep, generating patterns without any particular significance. If this is the case, then forgetting these meaningless dreams is a mark of efficiency. The brain conserves its precious resources by not bothering to store content that served no purpose. Only on rare occasions might a dream contain something worth preserving: a sudden insight, a resolution to a waking problem, a moment of important emotional processing, and even then, the brain's filtering system might not recognize it as worth saving. The border between memory and forgetting is not a sharp, clear line, but a fuzzy, indistinct twilight zone. While some dreams are clearly remembered and others are completely forgotten, many exist in a hazy middle ground. You might recall times something significant happened without remembering what times it was. You might retain a single, powerful image, stripped of all its context. Or you might wake with a lingering emotion, a sense of joy or dread without any story attached to it. These partial memories demonstrate that forgetting is not an all-or-nothing event. It is a gradual process of decay, with some elements proving more resilient than others. Typically, emotions tend to last longer than facts, and broad impressions outlast specific details. Every night, your mind creates entire worlds while you sleep. During REM sleep, your brain constructs vivid, immersive experiences from a collage of memory fragments, ambient emotions, and abstract patterns. Characters appear out of nowhere, complex conversations unfold, and sprawling landscapes emerge, all generated entirely from within. In the moment, these dream worlds feel utterly real, complete with sights, sounds, and sometimes even profound physical sensations. Yet, upon waking, they vanish like morning mist. The sleeping brain is not a mind at rest. It is a mind at play, a master creator, exploring possibilities that waking life could never offer. We dream about what matters most to us, our deepest concerns, our relationships, our formative memories, and our hopes for the future. Dreams expertly weave together the most meaningful threads of our lives. They allow us to revisit unresolved situations, process difficult emotions, and sometimes even grant us startling new perspectives. This deep emotional and personal relevance strongly suggests that dreams serve important psychological functions. And yet, we forget them. The crucial work happens regardless of our ability to recall it. Your psyche processes, integrates, and heals itself during sleep. And your conscious memory of the event is simply not required for the benefits to take hold. The healing is in the doing, not in the remembering. Forgetting our dreams mirrors larger truths about the nature of consciousness and memory. The vast majority of what happens in your brain never reaches your conscious awareness. Most of our neural processes are entirely unconscious. Memory itself is profoundly selective, preserving only the tiniest fraction of our total experience. In this context, forgetting is not an error, but a normal, necessary, and constant function. Dreams simply make this process more obvious. They are experiences that feel vivid and real, but often leave no trace, reminding us that our consciousness is a selective spotlight, that our awareness is narrow, and that most of who we are exists far beyond our ability to know or remember. Perhaps the real question isn't why we forget our dreams, but why we remember any of them at all. Given the unique neurochemical conditions of REM sleep, the deactivation of key memory encoding systems, and the state-dependent nature of memory itself, the default outcome should be total amnesia. The fact that any dream fragments are remembered might be the true anomaly that requires an explanation. Maybe we only remember these pieces when something in the sleep cycle goes slightly awry when we wake up at the wrong moment, or when the transition between the sleeping and waking states is incomplete. It's possible that a night of perfectly normal, healthy sleep means complete and total dream forgetting. Some dream researchers are now studying dreamless sleep, discovering that even outside of REM, the mind remains active. Thoughts certainly occur during non-REM sleep, though they tend to be less vivid, less bizarre, and less narrative than REM dreams. These fleeting thoughts are forgotten even more completely than our most vivid dreams. If dreams are ephemeral, then the thoughts of dreamless sleep are like the ghosts of ghosts. Yet they happen. Your mind is never truly blank during sleep. Consciousness exists on a vast continuum, from vibrant dreams to vague thoughts, all the way to something approaching true unconsciousness during deep, slow-wave sleep. And almost all of it is forgotten. Dreams connect us to something larger than ourselves, a shared human legacy. Across all of time and every culture, humans have dreamed. Our most ancient ancestors dreamed. Future generations will dream. Every single person who has ever lived has experienced this nightly journey into strange inner territories. While the content of our dreams varies, the fundamental experience is universal. And just as universally, most of it is forgotten. This shared, collective forgetting is part of the human condition. We all carry within us experiences we cannot retain, knowledge we cannot keep, and visions that dissolve before we can fully grasp them. There is a profound beauty in the act of forgetting itself. If we remembered everything, our experience would become cluttered and overwhelming. The mind needs empty space to function. Forgetting creates that space. It is what allows the new to enter. Each night's dreams can feel fresh and original precisely because yesterday's dreams have already faded. Each morning can begin unencumbered by the bizarre, intense journeys of the night. This forgetting is not a loss, but a form of renewal. It is not absence, but openness. It is not a failure, but a kind of grace. Perhaps there are some dreams we are meant to forget. Dreams that process trauma, that work through difficult and painful emotions, that integrate overwhelming experiences. Maybe these dreams do their work best when we don't consciously remember them. The healing happens beneath the surface of our awareness. The integration occurs deep within neural networks we can't directly observe. In these moments, consciousness gracefully steps aside and lets deeper, wiser processes do what they need to do. When we wake, we are subtly changed by dreams we don't remember, shaped by experiences we never consciously held. Your forgotten dreams are not truly lost. They shaped your brain in the very moment they occurred. Neural connections were strengthened or weakened. Emotions were processed. Memories were consolidated and integrated. The dreams leave their traces, even without leaving an explicit memory. You are, in some small but meaningful way, a different person because of every dream you have ever had, whether you remember it or not. The forgetting is of the experience, but not of its effect. The dream's work endures. Accepting dream forgetting might be far easier than fighting it. Trying desperately to remember dreams can create frustration and even anxiety around sleep. Some people wake themselves repeatedly throughout the night in an attempt to catch their dreams, fragmenting their own rest in the process. Others stress over forgotten dreams, feeling they've lost something precious and important. But what if this forgetting is exactly as it should be? What if letting dreams go is part of their fundamental nature, perhaps accepting impermanence? Even in this small, a nightly realm of dreams, teaches us something vital about accepting impermanence everywhere in our lives. The scientific study of dreams continues to evolve. New tools, new methods, and new insights are emerging all the time. The cutting-edge studies we've mentioned, the dream database, the ongoing lucid dreaming research, and the latest findings in neural architecture, these all represent the current edge of our understanding. But so much remains mysterious. The fundamental questions of why dreams exist, what they are for, and why we forget them are still fiercely debated. Science can describe the mechanisms, trace the brain's activity, and measure the neurotransmitters. But the subjective experience of dreaming and its ultimate meaning remain in realms that science has not yet fully reached. Each person's relationship with their dreams is unique. Some people treasure the few dreams they remember, finding profound meaning and inspiration in them. Others barely notice their dreams at all and feel no sense of loss. Some desperately wish they could remember more, while others are grateful for the forgetting, especially if their dreams are frequently disturbing. There is no right or wrong way to dream or to forget. Your experience is yours alone. Whether you remember many dreams or few, whether you seek deep meaning in them or dismiss them as nightly noise, you are participating in something fundamentally human, and the forgetting is an essential part of that experience. Perhaps, above all, dreams teach us to live in the present moment. They arise from nothing, they vanish into nothing, and they cannot be held. Like everything else in life, they are temporary. Trying to grasp them tightly only makes them slip away faster. The nightly practice of letting dreams go might be practice for letting everything go, not with indifference, but with grace, not with resignation, but with profound acceptance. Dreams remind us that experience itself is ephemeral. They teach us that this moment, right now, is all we truly have, because memory is unreliable and the future is always uncertain. In their silent departure, dreams whisper to us, "Let go, let go, let go." And in that forgetting, perhaps, lies a certain kind of freedom. And so, our quiet journey through the mysteries of dreams comes to a gentle close. We've traveled from the silent work of the hippocampus during sleep to the MCH neurons that actively erase our memories, discovering along the way that forgetting is not a failure, but a vital function. From the complex chemistry of acetylcholine to the brief, brilliant glow of lucid awareness, we've glimpsed how consciousness dances at the very edges of sleep, creating magnificent experiences that dissolve like morning dew. Dreams remind us that experience itself is impermanent. So much of the mind's most important work happens in silence, far below the surface of awareness, in depths we can never directly observe. Our forgotten dreams teach us patience, acceptance, and the gentle art of letting go. Without forgetting, there would be no space for tomorrow's dreams. By releasing what we cannot hold, we remain open to what comes next. By pausing to notice this cycle, we glimpse the extraordinary, endless dance of consciousness awake, asleep, dreaming, forgetting, always changing. And now, in these final few minutes, I invite you to take the deepest breath you can, as deep as you can possibly manage. Think about consciousness itself, yours, mine, everyone listening, all awareness, everywhere, perhaps all connected in ways we don't yet understand. You are not alone in this universe of minds. Think about how every person who has ever lived has dreamed, and forgotten, and dreamed again. Across centuries, across cultures, this ancient rhythm continues. Allow your entire being to dissolve into this vast ocean of consciousness, into dreamless rest, into the quiet space that exists before thought. Prepare for deep sleep, where no boundaries are left, and only peace remains. If this thoughtful exploration of the mind made you feel a little less alone tonight, consider whispering it forward to someone else who might still be awake. It may bring a moment of comfort to one more wandering consciousness. One quiet share, one peaceful night at a time. But there is no need to do anything now. Nothing at all. You have traveled far tonight, through the intricate neuroscience of forgetting and the quiet poetry of consciousness. You can allow these thoughts of dreams and memory to fade now, just like dreams themselves, leaving only a gentle calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself is gently pulling you deeper and deeper into rest. If sleep comes, let it carry you like a soft wave, smoothly and inevitably, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, just stay there. Stay in the darkness that feels safe and warm. Tomorrow, dreams will still be there. Your brain will still create its nightly theater. Memory will still choose what to keep and what to release. But tonight belongs to stillness. Rest well, curious mind. And remember, your forgotten dreams are not lost. They have done their work in silence. You are changed by what you cannot remember. Fall asleep to gentle facts. Where science meets sleep. Dream deeper with bedtime science. Relax, listen, and drift into sleep. Good night.